So we have all these general rules for math, and the rules that we run for exponent properties were very individualized. So it's just one rule at one time. But when you're working with exponents, often you're going to have a lot of different things happening. And trying to make it simplified for the reader to look at is what we're trying to do. So we're going to be putting all of this together. So at the top I have x cubed y to the 6 over x to the 5th y squared. So there's a lot of different ways to attack this problem, which is true for a lot of these exponent problems. You can start like simplifying the top. You could simplify the bottom, right, the numerator denominator. You could start using your formulas right away. That's what I'm going to do for number 1. I have the quotient property, so that says x cubed over x to the 5th. Means I subtract the exponents. So as I keep simplifying this, it becomes x to the 3 minus 5. And then I have y to the 6th over y squared, with my exponent 6 and 2. And that same property says that I subtract those exponents together, right? 6 minus 2. And from there we get x to the 3 minus 5 is negative 2. And y to the 6 minus 4. I'm sorry, 6 minus 2, jumping ahead, which is 4. Okay. And I'm not done because I have a negative exponent there. So I have another step. Whenever I'm giving an answer, I'm simplifying these exponential equations or exponential expressions. I don't want to leave a negative exponent. Okay? So I have to use my negative exponent rule, which means I cross the line, okay, and change the sign. So that's that imaginary imaginary line that's right there. So this final answer becomes y to the 4th over x. And because I cross the line and change the sign, it's over x squared. Okay. Now, eventually you're going to start doing these problems, and you'll do so many of them that you'll be able to go from here to here. Okay, just like that, right? Snap of a finger. Until then, it's helpful to write out these steps, okay? Especially if you feel like you're going to make a mistake. And of course, when you're in doubt, like really confused on what to do, what you can do is expand this exponent. So x cubed is x times x times x. Y to the 6 is y times y times y times y times y times y. Right? And then the numerator, you have x being multiplied together 5 times, and the same with y. So when in doubt, if you don't remember these rules, you can use the expanded form and just start crossing off like terms. And what you'll find is that you'll get the same answer. This is y to the 1, 2, 3, 4 over x squared. So I arrive at the same answer. Okay? Now, this method gets harder to do when you have problems like this, because you're going to be writing a lot of things out. But you can still do it. It's still possible. For our second example of putting it all together, we've got a lot of different rules we're going to have to be using, right? We've got a negative exponent here. At the top, we've got multiple variables to simplify and combine. So yes, we could expand it out, but let's try to use our rules and make it a little bit easier on ourselves. I'm going to look at all the terms that have x. Okay, I've got x squared, x cubed, and then x squared on the bottom here. What I'm going to do is I'm going to circle all of the exponents so they stand out. Okay, I don't have any other x's. And I'm going to write x to the, now when I'm multiplying these together, I'm adding the exponents. Okay, so think of like, if they're both on the numerator, I would add the exponents. If they're both in the denominator, I would add the exponents. Now, I've got this row, right, 2 plus 3, and then I'm subtracting the exponent that's at the bottom, right, in the denominator. So 2 plus 3, and then minus 2. So what I'm doing is I'm combining this rule that says if I'm multiplying two numbers with the same base, or two powers with the same base, I add the exponents. And when I'm dividing, I subtract the exponents. So I'm putting all of that together, right? And I'm doing x to the 2 plus 3 and then minus 2. Right? Likewise, I would do the same thing with y. I've got y cubed here, y to the negative 2, and then at the bottom I've got y squared. So that's going to be y to the 3 plus negative 2 minus 2. So lastly, I have z. That's z to the 4th on the numerator and z to the 5th at the denominator. It's hard to distinguish a little bit between the red and the orange, but that's z, right? And I've got 4 in the numerator, so 4. Nothing else to add together here, right? So it's 4 and then minus 5. So when I do my math out and I add these together, again, once you start doing this more frequently, you're going to be able to do this right in your head, right? You're going to say, oh, this is x to the 2nd, x to the 3rd, well, that's x to the 5th. Subtract your 2 from this, so it must be x cubed, right? Well, same thing here. 2 plus 3 is 5. Minus 2 gives you 3. So that's x to the 3rd. And we have y. Y to the 3 plus negative 2 is just 1. And then minus 2 is negative 1. And then I've got z to the 4 minus 5, which is negative 1 as well. Now, I'm not done because I've got negative exponents, so I have to cross the line and change the sign. Right? These both have to go down. This z has to cross the line. This y needs to cross the line. So my final answer for this one is x to the 3rd over y to the 1st and z to the 1st. Okay, which you don't even have to write to the 1st power because that just shows that there's only one there, right? So x cubed, y, z. And that's it for example 2. So for example 3, we've got some, right, division in here. We've got x to the negative 2, y cubed, z to the 5th. And actually these are all have different bases, so I can't combine them together, right? But all of these are being raised to the negative 2 power. So that means if I use my product to a power rule, I am distributing this negative 2 in to each of these exponents. Right? So this first one becomes x to the negative 2 times negative 2. And this one, y, becomes y to the 3 times negative 2. And lastly, we have z. And this becomes z to the 5 times negative 2. And I put that all together. X to the, well, negative 2 times negative 2 is positive 4. So this becomes x to the 4th. Y to the 3 times negative 2 is negative 6. So that's y to the negative 6. And then we have z. So this is z to the 5 times negative 2, which is negative 10. And now I've got some negative exponents, which I can't have when I give the reader my final answer. So x to the 4th, that can stay the same. Okay. But y to the negative 6, I've got to cross the line and change the sign. Z to the negative 10, I've got to cross the line and change the sign. So my final answer becomes x to the 4th. Now z to the positive 10 is in the numerator, and y to the positive 6 is in the denominator. And that's my final solution right there. The next two problems I want to talk about, and you'll see that I changed them from the previous section of the video, so this is a positive 2 and this is a positive 2. But I want to talk about the difference between having these parentheses over the negative 3 and no parentheses over the negative 3. Okay? So when I'm squaring something, it means that whatever number is being squared is being multiplied by itself 2 times, right? So this is negative 3, and I'm multiplying negative 3 times negative 3. Okay? And negative 3 times negative 3 is positive 9. Now, that's a huge difference between this problem here. This is negative 3 squared. This exponent is only on the 3. It is not on this negative. So even though the negative describes what's happening here, right, it's negative 3 squared, this is actually negative 3 times 3. Because this square, right, this exponent of 2 is only being applied to the 3. And that's why you need parentheses around this one to show that, well, we're actually squaring negative 3, not just 3. Okay, so this one here is negative 3 times 3. 3 times 3 is 9. So that makes it negative 9, which is a huge, huge difference. Okay, so be very careful when you have problems like negative 3a to the 6th and negative 3a to the 6th. Okay? It's very, very different problems.